Unit testing is great. If we choose our test carefully, we can pinpoint logic errors and issues with our smart contracts. But with unit testing, we cannot say much about the properties of our smart contracts other than that they pass the test in these specific scenarios. As you can see in the diagram, we have time in the x-axis and the value of the redeemers in the y-axis. This plane represents all the possible combinations of values we could have. Assuming we have negative value of the redeemers here and positive values of redeemers here, and that the redeemers line separates the before and after the deadline, every one of these points is one of the tests we wrote. The 3 tests that run before the deadline that have to fail, as we see with the red color. The only test that is after the deadline but with a positive redeemer, it should also fail. And lastly, the 2 redeemers that are 0 and a negative value after the deadline that both should be successful. So as you can see, yes, we cover key combinations of values, but there's a lot of surface that we didn't cover. What we actually want to know is that if all the combinations of values result in something like this. This is what we actually want to know. That all the values in the red zone return false, and that all the values in the green zone return true. In reality, we cannot test every single value because numbers are infinite, but we can generate an amount of random tests big enough so our confidence approaches the one we will have in the case that we will have test all of the possible values. And this is what we do with property testing. When we test for properties, we provide statements about our code, and we have a library called QuickCheck that generates random values that check hundreds or thousands of times that the property holds. This QuickCheck library is a Haskell library. It's not specifically for testing smart contracts, so you can use it with whatever you want to use it. In this case, we're going to test the same validator we tested in the previous video. Let's get started. So let's get out of here. Let's go to VS Code. And here we have the main function. As you can see, it's even shorter than before, but the 2 important things that I want to point out is that now we're using this test property function that it comes from QuickCheck, and that the final functions take parameters, but we are not providing those parameters. Those parameters are filled by QuickCheck automatically. As you can see, all 3 tests take the same parameters and return a property back, that this property is the one that is tested. The first property tells us that anything before the deadline always fails. It doesn't matter which redeemer you choose. If it's before the deadline, it should always fail. Then we test for the property that a positive redeemer after the deadline also always fails. It doesn't matter which exact redeemer is. If it's after the deadline and it's positive, it should always fail. And finally, the last possible case, if we provide a negative redeemer after the deadline, it should always succeed. These are the properties or validator we want to test. Now let's go over the helper functions. It's actually 2 helper instances because we have here the same helper functions we used in the previous lesson, so we're not going to cover that again. But we do have 2 new instances. We need the testable instance for the run type because the Plutus simple model library uses this run type to wrap the state monad. Once this instance is created, it will be the same for all the tests. So you can think of this sort of like boilerplate. But Keep in mind that here we are initializing the blockchain with the default configuration of Babbage and 10 million coins to the admin user. Then we create this arbitrary instance because QuickCheck has a bunch of instances of this arbitrary type class, but those are for the most used types like integer, int, etc. But one of our parameters is a POSIX time. That is just actually a wrapper around an integer. So we have to create an instance for that specific type, which is actually pretty easy because we have this choose function that takes the minimum integer possible, the maximum integer possible, and it chooses one at random that then we can wrap again in the POSIX time constructor, and we get a random POSIX time. This is also kind of boilerplate. The difference is that you may want to change the minimum and maximum values in case you are testing in a different time range. Okay, let's go to the cool part. Let's skip all this. We already covered this in the previous video. Testing the properties. Here are the 3 properties that we are testing. Notice that all the properties take a POSIX time and an integer and return a property. And all the properties use this runChecks function that takes 3 parameters: a boolean, a POSIX time, and integer. This runChecks function is the one that we use to actually run the checks, and we provide a boolean saying if we expect this check to fail or succeed. In this case, it's false, so we expect it to fail, and provide a random datum, deadline, and a random redeemer. The actual checks are always the same. That's why I use the same function for all 3 cases. What changes are which values are allowed to be passed to the runChecks function. And for that, we use this expression right here, before this long path arrow. This expression right here takes all the values randomly generated and passed as parameters and filters them to the values that we actually want to check. Because when we consume the UTXO from the script is at a hard-coded time of 1000, this one, we want to filter the deadline, in this case, any randomly generated deadline that is bigger than 1001. So in this case, we will always try to consume the script's UTXO at the same deadline, 1000. But in this case, every time we are going to generate this UTXO with a deadline bigger than 1001. And because the deadline will be always bigger than the time when we actually try to consume the UTXO, it should always fail. And that's it. This is our first test. Notice that in this case, we ignore the redeemer. We don't care about the redeemer because we are already trying to consume the UTXO before the deadline, so we don't need to filter the redeemers. Either way, it will fail. Then we check the property that the positive redeemer should always fail after the deadline. We already checked that it should fail before the deadline because here we are regenerating both positive and negative redeemers. In this case, as you can see here, we are checking that the redeemers need to be positive and that the actual deadline has to be before the time when we consume the UTXO. So we will always try to consume the UTXO after the deadline, but because the redeemer will be always bigger than 0, it should always fail. And finally, the only property that should succeed is that negative redeemer should always succeed after the deadline. And here the only thing we change is that the redeemer has to be negative and that the deadline has to be smaller than the time when we consume the transaction. So in this case, it doesn't matter which values were randomly generated. As long as they pass this filter, this test should be always successful. The way that we force QuickCheck to respect our boundaries is that QuickCheck will keep generating hundreds or thousands of values, and only the ones that pass this filter are the ones that we give to the run checks function. But the values are still generated in the whole range we had initially. So if you happen to have an error that says QuickCheck gave up, check your filters, because maybe if you, for example, filter redeemer less than 0 and then also redeemers bigger than 0, you will filter everything and QuickCheck will give up because it can't find tests to actually pass to the run checks function. But in this case, we're good. So these are the 3 properties we are checking for. In all 3 cases, we use this run checks function, so let's go to the definition and see what we have. This function is an analogous of the one we have in the previous lesson, but there are a few differences. We have the should consume, we have the deadline, we have the redeemer, but then we have this collect with a tuple, this monadic property and check, and this check function we actually create, and you should recognize this code because it's pretty much the same we had before. As you remember, here's the step when we actually provide all the final values to the test values function, and we run the blockchain to get the final balances, and we assert that the balances match. As you can see, here is the actual test after everything we've done. And this part on the top, we can simplify by actually removing all this if we wanted to. As you can see, there's no errors, because the actually important part is this check function we create below. And then we're using this monadic function because we're doing our test with a monad, the state monad, and this property that takes advantage of the instance we created before. These 2 values, in this case, you can also think about them as boilerplate. And the thing I removed that I will add right now, all this collect part, it's a functionality QuickCheck provides so we can actually see which values are being generated and tested against our properties. It's just a nice way to investigate a bit what is QuickCheck doing. We're going to use this in a bit, but before we are going to run the test without that, and then we will add it so you can see the difference. And finally, we have the test values function. This is pretty much the same function we used before. Here we are actually running the blockchain. This is the one we use here. We set up the users, the value, prepare the spend, submit the first transaction, wait until the hard-coded time. We get all the UTXOs at the script because we know it's only one. We just grabbed it and pattern match to get the ref and the out. We create the transaction to consume the UTXO at the script. And then we create the values that we expect. These values depend if we should be able to consume it or not. If we should be able to consume the UTXO, then the user 2 should have a value of 1100. Else, it should have a value of 1000. We create the time interval and finally build the transaction with the previous TX, meaning this consuming transaction with the automatically generated datum and redeemers, but it should validate in this time interval we specified. And finally, if the user should be able to consume it, then the user 2 submits the transaction, else the user 2 also submits the transaction, but in this case, we state that the transaction must fail, because we're anticipating that this specific combination of datum and redeemer should deny the consumption of the UTXO. And that's it. We get the actual values at the end and compare the actual values with the first user will always have 900 because when you send value to a script, it will always succeed. But the user 2 should have different values if we expect to be able to consume or not. So we compare it to the version value 2 expected. And that's it. So let's try this out first without logging all the datums and redeemers. So Cabal test week 6 property testing negative redeemer time. And there you go. As you can see, all our 3 tests passed, and we can see that QuickChat tried 100 and test and discarded 120 because of the filters we added. In the second case, passed 100, discarded 320, etc., etc. But the important thing is that we tried 100 different combinations of datum and redeemer in the specified ranges, and all succeeded. So we can have a bit more confidence about the test. Of course, 100 is not close to what we can do. In a real world scenario, maybe it will be better to test 1,000 or 10,000 different times. But for learning purposes, that's good enough. Everything works perfectly, but before we go, I promised you we were going to check the actual redeemers. Let's go back. We added the collect, so now we can see in a tuple the redeemer and the actual deadline. We could add a small explanation or format it a bit better, but a tuple of values in this case is okay. So let's save, open this again. We need space and run the tests again. Okay, all tests passed again, but this time, let me scroll to the top. Quick check actually shows which values were tested. So as you can see here, we have the -1 redeemer with 1,164 POSIX time. This is 1% because it's 100 tests and it tried only once, so it's 1% of the test. But depending on the generator and the filters, you could have a different distribution. And as you can see, in this test, we say anything before the deadline always fails. We are trying to consume the scripts UTXO at 1,000 POSIX mark. So as you can see, all these numbers in the second position of the tuple are over 1,000, but this one on the left are both negative and 0 and positive. So awesome, works as expected. In this case, positive redeemer after the deadline always fails. So as you can see in this case, because we are consuming in the 1,000, we provide a deadline smaller than 1,000. So all these numbers to the right have to be smaller than 1,000, and all the numbers to the left have to be positive. We do a quick scroll. Everything good. We have even a 0 here. Everything good. Awesome. And finally, negative redeemer after the deadline always succeeds. So the same as before, but this time all the redeemers have to be negative, and because the deadline is always smaller than 1,000, this should always succeed. As you can see, all the tests were successful. Now, thanks to the property test we just ran, we have a significantly higher confidence that our smart contract works as expected.